Okay, so yeah, I mean, if you can, let's take a look what you got wrong. Maybe talk to me, talk to a tutor, whatever. Try to fix what it is that got you this time, and then I will replace your final exam part 1 score in place of this test if it's helpful. For example, if you got a 0 on this test, then you can still replace it with the final exam score. All is not lost. Anyone who bombed this test, it's not irreparable harm to your grade in here. You can still make an A. It's totally possible. It is not probable if you did badly on this test to make an A because, well, human nature and inertia, all that kind of stuff. But anyway, so if I had to summarize why students got problem 1 wrong, I would say that by and large it is due to carelessness with transitioning terms from left-hand side to right-hand side. Inattention to changing minuses to pluses and pluses to minuses. That is more often than not the mistakes. That is the mistake of, what's the word? That's the most popular mistake on page 1 of the test, is students just not being careful to, when they move things from one side to another, have the right sign. Now here, we get x equals 1, and a lot of people got that. There's a few people who didn't, but, I'll just stop. Are there any questions about how to do problem 1? So, all right. Let's look at problem 2. I think problem 2 is kind of more of the same, right? So I think the major thing people did was somehow found a way to get either 8 or minus 8 when they did the 26 minus 18, right? Which says to me that they're ignoring a sign. I mean, it's an understandable mistake to get an 8 rather than a 44 there, but it's just not right, or minus 8, depending on who you were. Any questions about problem 2? No? All right. Problem 3, you might have done it a different way, but when I see something like 4 times x minus 6 equal to 8x, I just say, I want to divide by 4, make my life easier, So 8 over 4 is 2, so we get x minus 6 is 2x. And so that quickly leads me to x equals to minus 6. Of course, we can check our answer, right? If we plug minus 6 back up into here, what do we get? Minus 6, which is minus 12. What's 4 times minus 12? It's minus 48. What's 8 times minus 6? It's minus 48, right? So we could check our answer. I didn't see a lot of people checking answers. I mean, I have not checked my answers here either, but, well, anyway. Problem 4, a lot of you just had one answer. There are 2 answers to the absolute value problem, so you have to deal with the plus and the minus case. A lot of you just had minus 1, which is, hey, that's great, that's part of it, that's half of it, but the other half is when 7 minus 3x equals to minus 10, and that leads us to 17/3. Now, if you plug 17/3 back up into the equation, what ends up happening is you end up with absolute value of minus 10, which is the other way you can get 10 from that. So there are 2 answers here. Any questions? No? Problem 5. I saw some, you guys made me laugh. Problem 5, some people wrote some crazy stuff here. So my favorite wrong answer is some people, and it wasn't just one person, a couple people said this. The first line is parallel. The second line is perpendicular. You can't know. Parallel and perpendicular, we need a pair of lines. It's a way of comparing 2 lines together, right? Parallelness and perpendicularity, these are not properties of a line. You have to have a pair of lines, So anyway, these happen to be parallel because if you solve both for y, you can see that they both have slope -1, and lines are parallel if and only if they have the same slope. And they're not perpendicular because for them to be perpendicular, the slopes would have to be negative reciprocals of one another, right? And that's not the case here. So, you know, if you got problem 5, I think this is true of all of these problems. I hope you're not completely lost on these problems, right? For the most part. I mean, I think you can see a universe in which you got these problems right. It's not a hard universe to imagine, is it? So imagine yourself in that universe for the final exam, part 1. And then that puts you in a universe where you don't repeat this class, which is a good place to be in, right? Like, because you don't want to take this class again. Again, you know. Let's see here. I mean, mostly you don't want to take it again because I'm not teaching it next semester, so you won't have the pleasure of my teaching. If you want to join me for elementary differential geometry, we're off. It's Monday nights. No, that's my technology and technology class. It's like Monday nights, 5 to 9:20. I think differential geometry is going to be Wednesday nights, 5 to 9:20. But I do kind of need you to learn some calculus and some like linear algebra before next semester. So you'll have to do that over break. No? You're in, Jason? Hashtag drop. There's you know, no possible way. I'm of course joking. I don't think that course would be relevant to any of your degree plans unless you're math majors, right? So none of this is relevant. You know, more than one of you got this right without doing a bit of algebra. Shame on me for making the numbers so easy. Some of you just looked at it and went, by figuring. The answer is 200 and 300. It's like, and I looked at the papers, I'm like, they're not cheating, they're just thinking. Dang it, I made it too easy. See, if I had made the length like 97 feet longer or something, then you'd have been, then you would have been in trouble. But because I made it 100, just keep it like this. So I had to respect it if you just used raw thinking to come up with the answer. I mean, I was annoyed at myself for letting that possibility happen. But really, we do want you to use algebra to solve the problem, right? So you label what you don't know, which is the width. The length is the width plus 100. The perimeter is the sum of the lengths of the sides, which works out to 4w plus 200. And then we can solve for w and get 200, which means the length is 300. A lot of people forgot to put the area, so I took off 5 points if you did that. That is easy to fix on the final, right? Just double check your work, make sure you've answered all the questions asked. A lot of people missed 5 points from that area question. A lot of people didn't too. I was generally very happy with problem 6. It makes me very happy to see you guys solve the problem without using algebra, just using thinking. That I don't object to that at all. I mean, that's fine. All right, so solve 3. All right, so up until this point on the test, I was like, man, there's be a really high score on this test for most people. Like this is going great. Hardly anybody's lost much up to this point. And then I hit the inequalities, and then things started to kind of fall apart, right? Because inequalities are hard. It's just the case, right? Okay, so I guess the question is, if you didn't get this answer, like what went wrong for you? Like what was the step that you were misled at? I don't know. I mean, if you come to my office hours, we can look at your test paper, try to look at it together. I can try to figure out where you went wrong, talk to you individually about it, you know, if you want. Or you could talk to a tutor if you're not comfortable talking to me. There are various tutors, especially if you're an athlete. They've got tutors coming out, you know, their ears. I mean, they got tutors upon tutors, right, for you guys? I'm pretty sure. Am I right? I'm right, right? I believe some of you are athletes. I mean, I know I'm not, but.
I am, but I haven't I don't know about it.
Uh-oh.
I didn't know.
All is not lost yet, but I mean, if you're in here, you need to get past this course, right? So there's no time like now. Let's see. So so here, what I did was I added 2x to both sides, right? So I moved the 2x to the right-hand side by adding it. I subtracted 5 to the left-hand side by subtracting it. So addition and subtraction of terms does not change the inequality. You can move terms from left to the right side by adjusting the sign of them. All right? 3 minus 5 is minus 2. And then what do I have? I divided by 2. Dividing by 2 is dividing by a positive quantity. That does not change the inequality. It's still greater than. So we have minus 1 is greater than x. For whatever reason, I do better writing that as x is less than minus 1. And so in interval notation, that means minus infinity to minus 1. By the way, if you had the right answer as we're going through this, and I've still marked it off, it may just be that I looked at your problem wrong or something. I do make mistakes. I am human, so don't be afraid to come to me after class and point out to me, hey, Dr. Cook, I think you're wrong here. I think I should have had maybe a point extra or something, like whatever. I will listen. I will look at it. I don't guarantee I'll give you your point, but I'll at least think about it. I personally, I had an experience as an undergraduate. I still remember I had this test. I got a problem. I got 3 points taken off of it. And I was like, And I looked at my solution. I'm like, I thought it was right. And then I became convinced it was right. So I went to the professor and I said, why did I lose points here? Isn't this right? He's like, oh, yeah, that's right. I was like, well, can I have my points back? And he said, well, it's just 3 points. I'm like, yes, but can I have my points back? And he would not give them. And it bothered me greatly. See, because I cared too much about points, actually, at that point. But so anyway, I will not be that professor. I will give you the points back. Although I am amused in retrospect that he was able to do that as a professor. I don't think that's a freedom most professors have anymore. I mean, if you did that, I think the students could like complain about it and you get in trouble or something. I don't know. That's what I feel like. But anyway, from a different time. So this one is, you notice that you might have asked yourself the question, why did I ask the same question twice? Because it's different. Exactly. It's very different. Less than and greater than are, the way you treat these problems is quite different. Greater than, you got to look for less than minus 4 or greater than 4. Those are two distinct cases. And they give you either x less than or equal to minus 6 or x greater than or equal to minus 2. So you got to take those two and union them together. That's the answer. In contrast, if we have less than 4, we just need that this quantity is between minus 4 and 4. So we can solve that problem as a compound inequality by subtracting 8 from both sides and then by dividing by 2. And notice that if you did these problems right, they're complementary in the sense that whatever's not in here is up there, and whatever's not in there is down here. If you put them together, you get the whole real line, right? Because if you think about the problem, we're saying this is less than that, right? Or this is greater than or equal to that. So it's got to be one or the other for every x. And that's why we get every x when you look at both problems put together. That's a way you could have checked your work if you happened to have that thought. I mean, if you're really lazy and you understood that, you could write that down and just write this down immediately. If somebody had done that in here, I would have given like 20 bonus points or something. I would have been like, whoa, awesome. No one did that. No one did that. Students surprise me sometimes, though. I don't rule things out. So minus 4, I subtract 8 across the inequality, then I simplify, then I divide by 2, and that gets me to minus 6 less than x less than minus 2. So again, I'm sorry if it didn't work out for you yet, but please don't give up and keep trying. Get a tutor, talk to me in office hours. I am here to help, believe it or not. Oh my goodness. I'm talking about anybody who made less than a C on the test. There are, 20, 30% of the students in here who fit that. And if you're one of those students, and I filled out you guys call it report card. Like the report card, it's like request meeting with student. So pretty much in there, I wrote like a little, hey, this student should come talk to me about their quiz 1 or test 1. I don't think I put test 1 because when I had to fill out the report cards last Friday, I hadn't graded anybody's test in the intermediate algebra, so I couldn't really say anything. So I think for you guys, I already graded your quiz.
I think you put on there that you had graded the quiz, but you hadn't graded the test.
That's what I wrote. Okay, so I put, sometimes I was getting lazier as I went on because literally everyone I'm teaching has a report card because you either have to fill it out if you're a freshman or if you guys are athletes. Or if you're just, it's absolutely, I opened this thing up. First of all, I didn't get the email for it earlier in the week. And then I'm like talking to Professor Giles and she's like, have you filled out your progress reports? I'm like, what? And then she sent me the email, I click on the link and then like, I was like, oh, I won't be going home early this Friday. It took me like 3 hours to fill those things out.
Yeah, my coach called me out about that.
Oh yeah?
On the test and
Uh-oh. So what I'm trying to say is if I put there that you should come like talk to me, it's not, I'm not calling you in to like rake you over the coals or anything. I just want to go over your test with you problem by problem and see if there's like something we can identify that you can fix. It's really, there's no shame in it or anything like that. It's just time to try to figure stuff out together. And if you don't want to do it with me, that's okay. I'm suggesting it would be good. If you think it'd be more productive to do it with like, one of the tutors in the Math Help Center or something, that's also fine. But I felt like I should put that there pretty much for anybody. I put, come talk to me for anyone who had like a grade of like less than a C. So again, it's not personal. It's just, I want everybody to pass in here, so. Oh my goodness. If the grade was just based on this problem, I would have to have everyone in my office. Almost like so much wrongness in the answers here overall. So it's probably my fault. I probably didn't spend enough time graphing in here, and I'm sorry about that. I'll try to hit graphing more as we go on at some point, all right? Any questions about this one? So the basic point is the x values go from minus 8. All right, we have an x value from minus 8 all the way over here. At minus 2, we're jumping down here, but then we come back up to there. We're still having an x. There's an x. There's something on the graph with that x all the way over here to 2, not included. Between 2 and 4, there's no graph, right? So that's outside the domain. So like I have to exclude from 2 to 4. But then from 4 to 8, I've got points again. So that's why I have minus 8 all the way over to 2. Those are the x values, which there's a graph. And then again from 4 to 8, those are the x values for a graph. The x values tell you the domain. When I look at y, I think about horizontal lines. And if you look at that, there's something that's in every y value all the way up into 8 and starting at minus 6. So I go minus 6 to 8 included for the range. So if you didn't get this yet, I think this is something you can fix before the final. I think everybody can get this right. It really is not that hard once you understand what you got to do. Is you got to look at, is there a point on the graph at that x? If there is, then that x is in the domain. If there's not, that x is not in the domain. So when I look at this, I just have to exclude between 2 and 4, there's no graph there. But everywhere else between minus 8 and 8, there's a point on the graph. So that's the domain. F of 0, so the input is 0. The output is minus 2. So this point here is 0, comma, f of 0, which you can see from the graph is minus 2. So f of 0 is minus 2. F of 3, well, that's in no man's land over here. There's no value for the function given there. So you could say not available or does not exist would be fine. Please fix this problem. Some of you did not do this right. It grieves me. Do not, please fix problem 11. You guys are killing me not getting this one. My favorite wrong answer here. I like this because it's wrong, but it's consistent. I had a couple people, not just one person either. A couple people, instead of putting the point here, you know what they did? They put the point, let's see here, at here and here. So they did like 4 over and 6 down for that one. And this one they put at 2 over and 6 up. So they changed the meaning of x and y. But they did it for both points. So I had to, I still took points off, don't get me wrong, but like, at least it's consistently wrong. More popular, though, was people just ignored the minus here and just put the point like up here, which is not what was given, right? Because it's minus 2, so it goes below the x-axis. Anyway, once you have those 2 points, drawing the line should be simple, right? Any 2 points determine a line, right? If they're distinct, so just connect the dots and keep going. That's the graph of the line. To find the equation of the line, we find the slope, delta y over delta x, if you like. It works out to minus a half here. There's a point. You can use point slope. There's the formula. If you simplify it, it's 1 minus 1/2 x. So a lot of people got this wrong, and I don't think that had to happen. I think if you're more careful with this one, you'll get it, right? How can we be more careful with this problem? Like once you're done with it, do what? Check it. How could you check it? Right, yeah, check your point. Maybe try plugging in one of the points into the formula, see if it works, right? Like I could try plugging in minus 6, 4. Does it work? Well, if I take 1/2 times 6, I get 3. So I get 1 minus a minus 3, which is 4. So yeah, when I plug in minus 6, I get out 4 from that formula. Now, what I just did, I talked about plugging in a number into a formula, right? You might not be comfortable with that yet. See, so that's a skill you want to get better at. You want to get better at evaluating a function because it won't just be that problem you get better at, right? You'll get better at checking other problems, you know? So, yeah. And then the bonus problem. I was actually, there was sort of a, it was like probably like the next national election, right? It's probably going to be about, honestly, it's going to be like 50-50 because they're always going to be 50-50 because that's like the way the power is balanced. So like pretty much any national election is going to come down to pretty close between whoever's, it almost doesn't matter who the candidates are. And so that's kind of how this was for voting for whether or not it's a function. I had like a bunch of yeses, I had a bunch of nos, I kind of had an equal amount of both. And unfortunately, the answer was definitely no. This is not a function y. Vertical line test, right? If we draw a vertical line through it, we get more than one point intersected, because what that means is that if you give me one x value, you have to give me 2 y values. That's not allowed. A function has to be single valued. So no, not a function. However, if you want to find the points where x squared equals to 4, now that's the part that was bonus. The part that was bonus was finding those points, because you had to have the idea that to solve x squared equals to 4, what do I get? I get x equals 2 plus or minus 2. And then I have to look at the graph, where is x 2 or plus or minus 2, right? There's 4 points where that happens, here, here, there, and there. And so these 4 points are the 4 points on the graph for which x squared equals to 4. And I had people get like half of the points. I don't think anybody got all of the points, but people got some of it. You got half? Did you say it was a function? You didn't what? Oh, you just said it wasn't a function. Okay, yeah. Yeah. Well, anyway, you're like, why you ask a bonus question? We're suffering in here already. What you doing to us? Well, I always try to, I mean, it's a university course. I should try to at least ask one question, which is not like one you've seen before, you know? That's just, I feel like it's my obligation as a professor to do that. And also, I like to give bonus points. So, you know, as a general point of order, don't spend a bunch of time on my bonus question unless you've got everything else like nailed down. But also don't assume that there's nothing you can do there. A lot of times, like the totality of the bonus question is difficult to get, but there's something else that's in there that you could do for partial credit, you know? So, any questions? All right. Don't tell my pre-calculus I went over the test in class, because I don't do it for them there. I just do this for you guys because, well, for one thing, we have time. But all right. So, let us I'll get it up there eventually. Ah. Get there. Ah. Oh, man. I've tossed it up there a bunch of times the other days. Ah, that's better. Okay, so let's talk about where we're going in here. So we've talked about solving equations a fair amount already in here. So I'm going to focus now on how to solve, how to work with polynomials. Okay, so there's some things we need to do. First of all, we need to try to multiply some polynomials. We need to make sure we can multiply polynomials with confidence and with clarity. Once we've understood how to multiply polynomials, then we can start attacking the question of how to factor polynomials, because what factoring is essentially unmultiplying them. All right, so we're going to start now with some examples of multiplying. Multiplying polynomials. So I'm going to let you guys work on, actually, this one's even, which ones have I already done in here? 1, 2, 3, was it? We did some of the polynomials, didn't we? Not at all? We haven't touched it at all? Okay, well, we'll start at the beginning then. So I shouldn't say multiplying polynomials, I should say and algebra. Well, that's not what I want to say. Ah, curses. Let's just say polynomial algebra and functions. So we'll get to multiplying here before too long. I have at least defined a polynomial in here, have I not? I did define a polynomial. I know I did that. I wrote that big ugly formula. We talked about the degree, right? So I'm going to add some examples and I'll let you work them out. These are not on your sheet, but I think they'll be good for us. So let's let f of x equals to 3x squared minus x plus 10. I want you to calculate f of 2 and f of minus 1 and simplify. Your answer. Once you're done with that, I want you to add the following polynomials. So, I make these formula sheets, these exercise sheets out by just going to your textbook and like cutting and pasting problems from my math lab, right? But one of my annoyances with your current batch of homework is there's not enough X's. I think you guys need to work more problems with the letter X in them just as a point of like, it's good for you. All of the homework in the book has different letters, which seems like a small thing, but I think where you are right now mathematically, like it helps to have the notation be more consistent. So I'm going to do more examples with X's in class to try to help with that, yeah. Uh-oh. Like for the first example?
Yeah.
Ah. F of 2, what's that mean? So yeah, I'm hearing plug in 2 for x. That's what this means. It means everywhere there's an x, we put a 2, and we work it out. So we do 3 times 2 squared minus 2 plus 10. And then we want to work those out and simplify it, right? So what is that? I heard 20. So 3 times 4 plus 8, right? Minus 2 plus 10 is 8, right? 3 times 4 is 12. 12 plus 8? 20, yeah. So there you go. F of minus 1, what's that? I just plug in minus 1 for x, right? Minus 1 squared is 1, right? So this is what? This is 3. Minus, yeah, plus 1, plus 10. I heard 14. I think we have a winner. There you go. What would be f of 0, by the way? I heard 0. What's f of 0? Yeah, f of 0 is 10. See, we don't need to think so hard about that one. If you just look at the formula, right? When you plug in 0 into a polynomial, what's going to happen is you're just going to pick out what's called the constant term. So the constant term also tells us where the y-intercept is of the graph. If I write y equals to a polynomial and look at the graph of a polynomial, where its graph is going to intercept the y-intercept will always be just whatever that constant is. So it's helpful for graphing also. Yeah? Oh, okay. How about the next one? Can we do the next one? And I'm just writing it down. I'm just writing it down. I haven't done anything yet. The question really is, in words, how does this work? Like, how do we add two polynomials? We have to add like terms, right? So, oh, which one? This one? Oh, good. Oh, I'm very gullible, so you know. X to the fourth plus x cubed, right? All right. Okay. Right. So, and this is what's this is the so-called standard form. I probably will tell you things like multiply the polynomial and put it in standard form. Right, this is the standard form. Why is it standard form? I'm here, and it's because you can't do anything else to it. You can't add things together. That's a good answer. But, I mean, my answer is much more boring. That's the definition of standard form. But, but you're right. That's why it's a good definition, is because the students can't do anything else to it. The other reason it's a good thing is it's unique, right? If you got a polynomial and you put it into standard form, somebody else has that same polynomial, they put it into standard form, your standard forms are going to match. Like, it's not like you can put it in standard form and Jason can put it in standard form and you guys get different answers. Like, it's going to be the same. Assuming no one made mistakes. So, let's see here. So I always assume students don't make mistakes. It's part of what's wrong with my teaching. But anyway, another example. Do you guys need to see another evaluation problem? We could do the one in the exercise sheet. This is actually a problem in your homework. This is exercise 1. So here we're told p of x. I can't shake the feeling like we did this already, but anyway. 2x squared minus 3x plus 2. And you're supposed to calculate what's p of 4 and what's p of minus 2 and what's p of 0. Ooh, p of 0, I'll do that one. That one's easy. 2. Haha. Sorry, I should behave. I'll give you guys a minute, see if you can do those. What we got? That's 32. Well, 2 squared is 16, right? I mean, 4 squared is 16. 2 times 32, 2 times 16 is 32. Okay. Yeah, I got 22 too. You might have changed that +2 to a -2 or something, maybe?
Got that one right.
Aha, there you go.
Oh, I remember what I was going to ask you earlier.
Okay.
What happens if we don't turn in any homework, but we like pass final exam and like these next steps?
Well, I think that means that your like grade maxes out at like, I mean, I don't replace the homework grade with the final exam grade, right? So I replace test grades with final exam, but homework you gotta do. Yeah, yeah.
What happens? What would I agree with?
I mean, if you made a C on the final exam, you'd get a D in the class, I think, or maybe fail it. I think the homework's like 150 points.
So if I make a B on the final exam, and if I don't do any homework, still get a C.
I think it's possible, but it's not wise.
I mean, I'm not just going for that, but like, I don't know about this online homework now. I'm telling you, get your paper, and I will have it all to you.
Hey, you know what? Fine. I tell you what. You want to work out the PDFs that I posted the PDFs, right? Those paper ones. You want to print them all out and write your answers out on that and give it to me the end semester? I'll take it.
Okay.
Why not?
That's what I'm doing. I'm going to print every single one of those out.
Let's get nuts. Why not? All right.
Literally, why not?
All right. So
We get the work done.
8. I mean, I'll take it. Anything I can do to get students to do homework. Let's see here. I'm not a slave to the electronic format. +2. However, there is a pretty rigid due. I mean, that I can't be like, you know, Christmas Eve, Dr. Cook, I'm going to get that homework to you. Like, that's not going to work. Like, I need to have it. I need to have the homework turned in, you know, before when my math lab's due, quote unquote due, I think December 4th or 5th. So you need to have it to me before then. And I've heard this nasty rumor. Have you heard the nasty rumor?
I don't know. You have to
Have you guys heard any rumors?
about us not going back over Thanksgiving.
That's an interesting rumor. I wouldn't say it on camera, but that's an interesting rumor. And so
That's what I don't know. That's what I. Is that a nasty rumor?
if that was true, then that would raise the question: how will you get your homework to me on December 4th or 5th? You're gonna mail it to me.
Put all my papers in the mail and send them.
Oh my goodness, what is happening?
Oh, we can come back.
I mean, do you live around here?
I live about 3 hours away. I live about 3.5 hours away.
So I guess what I would say is it would be wise to turn in the bulk of what you've done before so that if there's more to do after, then you only have to mail that part or scan that part, you know? That's all I'm saying is like,
How true is this rumor you've been hearing? Because if I go home, like I might honestly run away. Because I'm gonna go home and live with my family.
I really don't know any more than you guys know, so probably. I mean, I'm new here. I don't know anything. Let's see here. So, oh yes, I did the P of 0 for free. That one's easy, right? 2. Woo. By the way, this is one of your homework problems, yes? So I'm sorry, I've just done one of your homeworks. Okay, let's move on. I'm going to speed up the pace in here a little bit. Let's multiply. And put into standard form. All right, so let's do exercise 3, which is b plus 11 times b minus 9. Exercise 4, which is 4x plus 5 times x plus 2. Let's do exercise 5, which is c plus 4, c minus 4, all right.
I think you might got some. What did he just say?
How do we multiply? All right, guys. How do we multiply? FOIL. All right. So what you got? What you got for me? You got me b squared.
B squared plus 2b minus 99.
But I'm gonna put down one more step. 11b minus 9b. Right?
Oh, you did simplify.
Yeah. I'm not simplified yet. So what you just said was b squared plus 2b minus 99. There you go. Very good. Listen, so here's, you have this FOIL method, great, fine, but
I did the way you did that way. We need that. That's the way I was taught. That's the way I learned. That's the easiest way.
did I do it wrong?
Okay, so basically, the way I was taught, you draw a line from the 4x to the x.
Uh-huh.
Yep, that's how.
You first, and then you draw 4x to the 2.
Yep.
And then you go from the 5 to the x, and then from 5 to 2.
That's how I was taught.
That's how I learned it.
That's how I was taught.
That's good.
Can we stay that way? Please. Can we stay that way? Please.
I wasn't taught that way, but it seems pretty easy that way.
So so what you're telling me is it would offend you greatly if I was to write the following.
Yes.
So this is actually why what you're saying is true, is because we use the distributive property once and then a second time.
And then did you add the middle two together?
Mm-hmm.
You got it.
Now, I'm fine with you not writing, I mean, you don't have to write down, I think it's totally possible, indeed healthy, to go straight from this to what's boxed. I can do that. You can do that if you want. Oh, the middle stuff's fine?
See, that's a good looking equation that you just wrote right there. That second one,
Oh, yeah?
yeah, that one we just worked out together. Yeah, that was pretty nice.
You like that? Okay. I mean, I wouldn't disagree. I mean, I don't know. I guess. I mean, my C's are kind of ugly.
The way we did example 3, that's like
Oh, that was perfect.
The second's the down piece.
I'm not familiar with this nomenclature, but. So this one is poor planning on my part, so I'm going to do one of these guys like that. And so how you gonna do this with your foil, huh? How are you gonna foil now? So Kennedy's telling me to multiply the first. Kenny, will you tell Jason to be quiet? You gotta tell him to be quiet. There we go. See- So you.
I'm just telling you that the board is going to be negative. Nope. I can't. Get on that.
I don't know what's going on here. Where'd my colored chalk go? Oh, here it is. So I agree with you. I think it's easiest to multiply these two first. Multiplication is associative and commutative. So like you could do these two first and then multiply by that. Or you could multiply these two first and multiply by that. Shouldn't make a difference, actually. But I think you're right. These two are easiest because when you multiply, what do you get? You get c squared plus 4c, right? Minus 4c minus 16. And so, of course, what happens there is these guys do what? They cancel, and we're just left with what? C squared minus 16 times c squared plus 16. And then we can FOIL again, right? So yes, c to the fourth minus 16c squared plus 16c squared minus 256, right? And that is equal to? There you go. Very good. Listen, there's a pattern here we need to take note of and to be looking for and to use, right? There's a special pattern. What is it? How about this? A plus B times A minus B equals to A squared minus B squared, right? So this is the so-called difference of squares. Of squares formula. So like that's what happened here, right? We had like c plus 4 times c minus 4, right? C is my A, 4 is my B, and we ended up with a squared minus b squared over there. Actually, that happened again, didn't it? See that? This is also like a minus b times a plus b, and we got a squared minus b squared. Actually, there's differences of squares. It finds differences of squares here. It's like difference of squares all the way down. Like, I don't know. Kind of. I like this problem. It's really neat. All right. Anyway, that's just something to look out for. Okay. We will add other special patterns to our list of. What's that? Like what? Like yeah, yeah, exactly. It's a factoring pattern to look for, right? It's a special pattern. Now, can you guys do exercise 2 plus I or 3 minus I?
So what?
Well, I made this example complex.
What's up with 2 plus I?
Well, I is the square root of minus 1.
Huh?
I is the square root of minus 1. So like I squared is minus 1. So 2 plus I It's an element of the complex numbers.
I think I'm moving too fast.
I mean, it's just a stupid joke. So I'm saying that this example is complex.
Alright, well, we can try it.
Mostly it's because I've already exhausted exercises 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh, I didn't get to 30. Only 28. So I need to invent some other numbers to stick in this list. So I see that. There's no reason. I'm just being an idiot, in summary. I could change the label to something else if you'd like.
Oh, no, I was there, no problem.
Oh, okay. How do we do that? Can you guys tell me? What's that? Yeah, exactly. We just distribute through. This is x times x cubed, right? Plus 3x times x squared minus 8 times x. And what's the basic rule that we've already been using, but add the exponents, right? So that's x to the fourth plus 3x cubed minus 8x. There you go. That's all there is to it. Aha! Aha! Foil that! See, that's the problem with FOIL. Unless you understand what underlies FOIL, which is the distributive property, then you're fine, right? You could say, but the FOIL here is those arrows you're drawing, right? You could say, well, it just looks like, it looks like this, right? And then right? It's just that there's 6 terms, right? And that's right. If we have a trinomial times a binomial, something with 3 things and something with 2 things, then the answer is something that has 6 things before we can collect like terms. And that's like generally the pattern. If you have m things times n things added together, the result is mn things. M as in mommy, n as in nanu nanu. That's a little Mork and Mindy reference for you there. Anyway, so x to the fourth. But honestly, guys, I'll be to be totally honest. Like, I wouldn't do it that way. Like, I think this line way is a bad way. Here's the way I would encourage you to do this calculation. Put that x squared first because it's easier, and think about x squared times this, and then I'll say plus 6 times x squared plus 3x plus 2. I think it's just easier to organize the work like that. Because that's going to get all 6 of those products that you're interested in. But it's got them in a nice order that's easy to think. What's that? Mm-hmm. This is just the distributive property. And so then you get x to the fourth plus 3x cubed plus 2x squared plus 6x squared plus 18x plus 12. Where'd that come from? Now we're not done yet, right? What do we got to do? We got to, right. So we got x to the fourth plus 3x cubed